Hi, I just wanted to create a video on a problem that I think a lot of students may get wrong on the Chapter 3 test that starts soon, but they only get it wrong because they forget some of the definitions and how it works. And I think this quick review will help a lot of people get this type of question correct on the upcoming test on Chapter 3. So it's about finding derivatives with the limit definition. Remember, we have learned all these shortcuts now, like the power rule and the chain rule and the quotient product rule. But I want to remind you how in section 3.1, we found derivatives using this limit definition. And I think part of the problem is a lot of people forget what the definition actually is. And that definition is that if you have a function f of x, then its derivative f prime of x is equal to the limit as delta x approaches 0 of this thing we call the difference quotient, right? F of x plus delta x minus f of x all over delta x. So our challenge is to take a function and express this difference quotient in terms of that function and take the limit as delta x approaches 0. So, for example, say I gave you the function f of x equals 5 minus 4x, okay? To use this definition, of course, this f of x is what goes right in here. That's what f of x is. We also need an expression for f of x plus delta x. And remember that that's just an example of using function notation, right? We're replacing x in the original function with x plus delta x. So you get 5 minus 4 times x plus delta x. I'm just going to reduce that a little bit right now. It's 5 minus 4x minus 4 delta x. So when you're writing out this limit, for this example, your limit would be of the function f of x plus delta x, so this expression right here, 5 minus 4x minus 4 delta x, minus the original function, so 5 minus 4x, all over delta x. And we want to evaluate this limit. And remember, the challenge is that we can't just plug in 0, because if you plug in 0, you get a 0 in the denominator, and that doesn't tell you whether or not the limit exists or what the value of the limit would be if it exists. If you have that 0 in the denominator, it doesn't tell you anything. So I'm just going to simplify the expression, the function we have in here, our difference quotient. It'd be 5 minus 4x minus 4 delta x minus 5 plus 4x, just doing a little distributive property. Then if you combine like terms, you'll notice that the 4x's would cancel out and the 5's would cancel out, right? So 5 minus 5 and negative 4x plus 4x, those would be gone. So you get the limit as delta x approaches 0 of negative, oh, this should have a delta x in it. I forgot to write that in there, right? That should be 4 delta x there. So you'd have negative 4 delta x all over delta x. And of course, the delta x's could cancel out. So in this case, you would just get negative 4 as your derivative. Now, we knew that, right? With all the shortcuts and the power rule that we learned before, we could definitely look at this function and just easily do that power rule and say, yeah, the derivative of 5 is 0. The derivative of negative 4x is just negative 4. So, of course, our answer is negative 4. But on one of the questions on the test, I ask you to use the limit definition and not just those rules. So even though using the shortcuts, you know what the answer is, in that question, you want to use this long limit process in order to show me that you know how to get there, how to use the limit definition to get there, and not just the other rules we've learned in the course. I really hope that helps people with this question. It's going to be on this upcoming test. Good luck, and please email me if you have any questions.